welcome everybody. My name is Greg Paulsen from Xometry, and I'm just really excited to share this manufacturing success story with you. Before we get started, I just want to lay down some groundwork in our agenda. We're going to start with some introductions. Or actually, I'm gonna quick poll at the poll at the very end of this, so I kind of move that around a little bit. So we're going to go with some background of our companies and jump into the design and the manufacturing of this macro keypad that we did for Autodesk Factory Experience, which is actually in Las Vegas a couple weeks ago. So it was a really great event, and we got to show off the awesome keypad, and a bunch of people had a chance to put one together themselves. We teamed up the Fusion design team for this project, and we utilized 6 unique manufacturing technologies, including sophisticated injection molding and overmolding techniques. What's great about this event is we're here, we're live right now. So you, the audience, you have an opportunity to submit questions at any time using the Q&A tab on the GoToWebinar feature. So you should see that questions tab, and just feel free to submit at any time. We're going to spend time at the end to go over as many as possible, as well as we'll be able to get back to you if we aren't able to answer during this live event. I'll get back to you with any answers for your questions as well. This webinar is recorded. We're going to send an email with recording for you to rewatch and share with your colleagues. So, jumping right into things, just very, very excited to have today's presenters here. I'll start with myself, and then I'll let Scott and Jonathan introduce themselves as well. My name is Greg Paulsen, and again, I'm the Director of Applications Engineering at Xometry. My job is to spin CAD and talk about cool parts all the time. I work with customers every day, looking at their projects and help them determine what to choose and why. I've spent 15 years in advanced manufacturing space, including additive manufacturing, as well as traditional technologies like machining, sheet metal, molding, and you name it. So just have a lot of experience working at any stage in that product development lifecycle, and have the privilege of working with Xometry customers, and it's always a fun time. Scott, I'll let you give an introduction.
Yeah, thank you, Greg. Good afternoon, everyone. Scott Benson, I'm our business unit manager for the molding department at Xometry. We handle die casting, injection molding, urethane casting, extrusion, plastic, and metal. And we have a wide range of projects that we work on a daily basis. Me personally, I have 14 years of manufacturing experience, ME with an MBA and RJG Master Mold certificate. So yeah, look forward to answering any questions and talking through the project with you. Jonathan?
Yeah, thanks, Scott. I'm Jonathan Odom. I've been at Autodesk for about 10 years now in the design and manufacturing group, specifically Fusion 360. I'm a community manager, which means I talk to customers, I put events together like the one we'll be talking about today. And I also have anecdotally worked in every industry Autodesk serves as a customer in the past before coming to the company to work for them.
Yeah. Jonathan has the coolest job in the world, and you'll see why in a few moments here, but it's pretty awesome to be kind of like the everyman for everything, and build a gadget. Like, your job is to build a gadget that other people can experience too, which is just super awesome.
I'm surprised every day that they actually pay me to do this.
I know, right? Yeah. But this is so I'm going to jump in and just talk a little bit about, for those of you who are not familiar, what Xometry is, and then we'll talk a little bit about what Autodesk is before we get into the project details. So Xometry, we serve a very wide customer base. We serve over 48,000 customers, and we're connected over 10,000 suppliers, and we use AI and machine learning to actually make a tool that makes it easy for you to get quotes and procure parts on demand. So think of us as a marketplace like what you've seen other marketplaces such as Uber, but we're Uber for manufacturing, or how Amazon's a marketplace that's disrupt retail. We're disrupting manufacturing the way where your custom designs, you can securely upload to Xometry's quoting system, get pricing and lead times in real time. We use AI and machine learning to provide that pricing, and then just press buy, and we take care of the rest. No matter how big or small that project is, we carry over 20 different manufacturing technologies, and we essentially are able to manage that workflow from that quoting inception through to the fulfillment of those projects, or multiple fulfillments within for example, production life cycle of this. And really it comes down to being that bridge between buyers and sellers. So we solve those headaches of getting an RFQ and waiting, or figuring out, hey, who can make my parts? Because we have one consolidated website, you could just upload and create your project in real time, 24/7. And then for those suppliers as well, they may be the perfect supplier for you, but may have no idea that you exist. Xometry makes that connection based on the specs of your part. So what are the needs for that part to make it most successfully, depending on its process, materials, features, finishes, quantities, timeline, all that is involved, and we make that matchmaking for you and assure quality throughout that entire process. And at the very end, I could answer any more questions on there, but I really want to say, like, we are just the every shop, if you will, some place where you could go with your 3D file, upload, get quotes, buy, and we help take care of the rest.
Yeah, and I'll tell you a little bit about Fusion 360. So Autodesk, as you may know, is a company we make software for making things. We service architecture, engineering, construction, media and entertainment, and product design manufacturing, which Fusion is kind of the flagship product for. It's a cloud-based CAD, CAM, simulation, kind of all-around tool for any kind of manufacturing. Personally, I focus on consumer products. That's something we're pretty big on there. It's also very big in the manufacturing space. It's cloud connected, so it's cross-platform. You can use it on a Mac or a PC. We're moving towards device independence, so that's not even going to be really an issue soon.
Awesome.
And you basically have every step of the process there. So product definition, you've got 3D modeling, drawings, all the standard stuff there. Engineering includes all your analytical tools, finite element analysis, all kinds of different simulation, generative design. And then the manufacturing side of it, it's kind of a one-stop shop for that as well. So whether you're talking about 3-axis, multi-axis, different processes, turning, milling, additive, all that stuff is built in. And then we also have shop floor management. So it's a really popular tool for that. One of the things I find customers like the most about this is that they've got their own app, their own system set up, how everything the way they like it with Fusion, managing their team and so on. But they can constantly share with anyone without that person having to sign up. So you can just send them a URL, opens it up in a browser, and you can spin the model around, make comments, all that stuff. So it really easily kind of is the fusion between all these different things.
Yeah, that's actually something during this project we use a lot to communicate, especially on updating of revs and just getting the latest assembly, looking at what's integrated into what. So it's a fantastic tool for communication, technical communication, annotation, visualization, and of course, from the design end, it's just a top-notch design tool. Something to note too is that we have an app, so we have a relationship with Autodesk with our app for Fusion 360. So Xometry's tools can also be accessed in your design environment. And that includes getting DFM feedback and getting pricing on your model as you're in the design stage, which has a lot of benefits to it, especially if you're trying to figure out, hey, how much does that fillet cost? You can check it out with the app. So let's talk about this project though, and this is the bulk of our conversation today, is really just going into these details because they cover really what Autodesk is, what Xometry is, with a real case scenario. So this is the macro keypad that we made for Autodesk University for the factory experience, and this is a picture of the real keypad made. I also got my Xometry blue version behind me, hooked up to my personal laptop because it glows when it's hooked up to a computer, and so I just want to show that off in the back as well. And I just want to talk to Jonathan a little bit about this project, and first off, what is your job? What is the factory experience? And then, tell me a little bit about what you got to with the macro keypad.
Yeah, so a big part of my job is every year I design, develop, and manufacture a consumer product. And then we have a working factory on the show floor at Autodesk University. We've also done this at on a smaller scale at some other events. The big idea is that, as professionals, we're all siloed. If you're a mechanical engineer, you may never set foot in a factory. You certainly wouldn't be ever assembling products. But what this does is shows you everything from concept to production, kind of all in a live experience. You get to see our partner machines working, making the different parts of the device, examples of the parts of the device. You talk to each of our partners to learn about what they do and how their products integrate with Fusion, just like Xometry. And then at the end, you can see in the photo there, there's basically a set of assembly tables and instructions, and you assemble the device and take it home. So this is the sixth product I've done for this. It's kind of taken some different forms and a little simpler and sometimes more complex products in the past. The big idea here is that we want to give attendees something they might actually like, something you might want to keep. But the main thing is that it's showcasing as many different manufacturing processes as possible. And Xometry, of course, produces the manufactured product, the production run. Think of it that way. So we have these machines on site showing how you would do like aluminum turned version of that knob you're seeing there, for example, or a milled aluminum version of the injection molded enclosure, which would cost 100 times more than this, probably maybe even more than that. But the idea is that you're seeing how the machines work. You see the whole process. You put a product together, and it ties in the whole story of from design to production.
Yeah, and this is, as you said, it's a desk-worthy device. Like, it is a keypad that has pre-programmed in it macros for different Autodesk softwares from Inventor, Fusion 360, Revit, Maya, and as you toggle through, it'll change kind of its color codes, and as well as show different macros at the screen here at the top, and you're toggling through with this little knob. So, it definitely does have function, and I think that's something really neat because it is something that has some lasting power. Like I said, a desk-worthy object is always a great object. We did last year as well, and this is another webinar we actually did with Autodesk, but we talked about a smart badge, which was our first experience working with you, Jonathan. This was a badge that would integrate with other badges and be able to do communication and other tools with this. So, very cool project that we worked on. So you came up with the keypad design, but you didn't just start with the manufacturer, right? You didn't just start with production. Can you walk me through your product development process and just a little bit of the stages, trials and errors, and what you found along the way?
Sure. Yeah, we decided on the on the macro keypad in sort of a brainstorming session early in the project. So you have a few people to get together. We all work together to to make this happen. Everybody had maybe their top 5. We start talking about them, and then eventually I make a decision on which one we're going to go with. This was the obvious contender from the beginning, just because being a macro keypad, it's something you can use with any Autodesk product. So there's an obvious tie in there. But also, we're all on our keyboards all the time, and there's a whole world of custom keyboards out there that we thought would be really cool to kind of plug into. So that's why we decided on this. The starting point for any consumer product is a prototyping board of some kind. You pretty much always start there. Luckily, in this case, when you're talking about a keypad, there are some decisions that are already built in. So you're going to be using standard switches, Cherry MX in this case. What your switch arrangement is going to be. There's very limited options there on what actually makes sense for this type of thing. And this being based on a number pad like you'd have on a phone. Once again, there's another decision made for you there. 3 by 4, giving you 12 switches. The prototyping board you're seeing there, the black one with the astronaut on it, is an Adafruit product. They make prototyping boards, but they were also able to do a custom production run for us on this. So one of the things we wanted to change about their board is that the LCD screen is stuck to the PCB that you're seeing there, where the astronaut is. That obscures the view. When you have switches and keycaps on it, you can't really see the screen. And then the other problem with it is that it had a vertical encoder on it. So then you have to use 2 fingers to make a change with the encoder. So we changed it so that the screen would float and you'd be able to attach it to another feature on the device. And then we also added a horizontal encoder so that we could have a knob you could roll with 1 finger. So it's kind of an ergonomic concern there. As far as design and prototyping, we start early with knowing the things that we're likely going to produce in the future. and those tend to be injection molding, right? So you can sink the cost of injection mold tooling. So the keycaps, that was obviously going to be injection molded. We'll get into that later. There's actually kind of a special feature about those. Then with the enclosure, we figured that probably would be injection molded too, just given the size. It would have been kind of prohibitively expensive with additive. And we also wanted to showcase some of Fusion's product design tools that, integrated clips and bosses and stuff like that are all in there. Not to mention draft angles and, setting part lines and all that stuff. You're actually seeing an injection mold simulation in a 3D printed representation right there next to it. So that's not just psychedelic. It's actually showing you the heat patterns that in a simulation for injection molding. We knew that the base, again, needing to show as many kinds of manufacturing as possible. We wanted to do that in milled aluminum because a device like this needs to have some weight to it. If it's all plastic, it's going to feel kind of cheap and move around on your desk and so on. So we knew that's what we would do with that. I actually prototyped that on a Bantam mill in my own garage. And then some of the other things you're seeing here are fit tests for the other parts. So that knob right there, and the Fusion F keycaps with color coding. Those are all increments of 1,000th, trying to get the right fit so that we'd know exactly how this stuff was supposed to fit together. Kind of an interesting anecdote there. The colored Fusion F icons that you're seeing there, that was Greg's way of saving me from myself because I forgot to emboss serial numbers on these. So he was just like, okay, red is 0.001, yellow is 2000s, green is 3000s, and so on. So I was able to get those back very quickly, like in 48 hours, basically, test them out, figure out exactly what tolerance we needed for that process. There's some FDM parts. So that the first set of rubber parts there to the left, those are done on an FDM machine. Again, something I have access to. You can kind of start to approximate with that, but it's going to be nowhere near the tolerances you'd have with the HP multi-jet machine that the production was done on, which is the next set you're seeing to the right. Those about the dyeing process, so they've got this kind of gray look to them, not really a finished product, but enough to test things out and make sure everything fits. And the keycaps, again, that was all FDM 3D printed. So, as many examples of these things as you can get. Resin printing to try to get some more high resolution stuff and kind of understand how the clips might behave and that kind of thing. So yeah, that's all prototyping.
Yeah, and I think that's what's important there is like you're using what you had on hand for you had a lot of in-house machines or quick rapid prototyping machines that help you bridge the gap and get closer to where you need it on your final product. And I always say like SLA, for example, is an insurance policy before you move the molding because it has a high dimensional accuracy compared to CAD. Where some processes, like if you're only using a desktop FFF machine to prototype injection molding, you may be in trouble or may have some design revisions needed when you're kicking off, especially when you have a fit assumption and then you're moving to a molded product, which is much, much more accurate to the CAD than FFF, which you may be compensating for. But going with that, I mean, you had a lot of in-house tools, but ultimately you sought out Xometry. So just tell me about that. Why'd you seek us out, and what did we add to the equation?
Well, I think the main reason we sought you out is that we had already gone with two of your competitors in the past and weren't really satisfied for a number of reasons. We had problems with quality control, with parts having the finishes that we'd specified, having surprise specifications we weren't expecting. Costs not really being under control, surprises about that would come late in the game, costs generally being much higher than what Xometry can offer. So those are all reasons we were looking for a new manufacturer. I think I tried you guys out because of the Fusion add-in that you mentioned earlier. So you basically there's a little window comes up and you sign in and then you're in the Xometry, you're connected to your website basically. You can upload files directly, and then the website was just very easy to use in terms of managing multiple parts, managing revisions, all that stuff being consistent with what I've got on my side in Fusion. And the estimates were really high resolution compared to what we're used to with some of your competitors. the suggestions that come up are like, it's not going to suggest something ridiculous that would cost, $1 million to produce, right? It's, it pretty clearly in the beginning says, yeah, you probably want to injection mold this. Here's what we think. And the final costs were very close to what the estimates were, with the exception of keycaps, which were like half of what I thought they were going to be in the end. And we'll talk about that later. But yeah, it's sort of a full package. It's easy to use your product. Quality control is always on point. Never had any problems with that. Quick communication. Last minute revisions were no problem. Making sure everything gets done on time the right way. It never feels like a black box. You guys are always communicative about how long things might take. When do we really need to get this in to make sure we're not, putting too much pressure on our suppliers and all that stuff. So I really can't say enough good things about Xometry, to be honest.
So first off,
and they're not paying me to say that.
Yeah, first off, thank you very much. And secondly, I think that's, something about a automated system. A lot of people think like with the technology driving behind Xometry, they're automated so we're hands off, but actually allows us to be more intimate with projects if you need them. So I always tell customers you can interact with us as much or as little as you'd like, because we do have a 24/7 instant quoting platform that just gives you that access. But in cases like this, especially integrated systems, we want to have this conversation because we use a lot of processes. And for your point, we wanted to celebrate the diversity of manufacturing that we could do. So you're not shopping around for all these different suppliers. We were able to really accomplish what you needed, which, by the way, is passing the test, right? Because other people needed to assemble this too. It's not just your project, right? It's a project for the people at the event, and also show off a lot of different technologies at one time. I have a summary here, and we're going to go individually in depth in each one of these, but just kind of showing you the diversity that we did in this tray broken down. So we made the base of it with CNC machined aluminum. The frame was laser cut. We used HP Multi-Jet Fusion for the soft touch components. A rigid ceramic knob was made with LSPC, which is a new resin-based printing process that we offer. The branded keys, so these kind of like full color keys, they're printed all in one piece here, and that's using a process called PolyJet. And then those enclosure and keycaps, given the details, the cosmetic requirements that they have, and the quantity, made sense to injection mold. So I'm going to jump through, and a lot of this, I'm going to give Scott his time to shine in a moment here, but a lot of this is around the molding efforts. But I do kind of want to show what some of those products look like on the floor of the factory here. So this is the machine tray. So it was milled 6061. This would be a 3-axis machining, pretty low cost because it's a shallow part there, and it does have a finish for protection of clear anodized finish as well on that. And this is the tray that the final product that we built in quantities of hundreds for. The laser cut frame was acrylic, nice clean acrylic. It was funny because you saw during the factory experience a bunch of little blue peels everywhere, because usually when you're cutting something, a cosmetic surface treatment, it comes with kind of a plastic wrap on those faces. And so people who assembled this also had that satisfaction of peeling off that protective film as they were putting together these parts. And actually, Jonathan, question on this, because it was used essentially, it's behind the scenes, it's inside the product, but that's essentially to take strain off of the PCB, right, and ease assembly. Is that kind of why you have this frame?
Yeah, it has a couple functions. One is that, I guess this is the main one, is that it aligns all of the switches so that they don't have slight angles to them. So there's a little bit of play when you plug these things in. They're hot swappable, and there's components on the circuit board that are allow for a little bit of play there. So if you put them together without this, it doesn't look totally aligned. You get some weird little angles in there. And then the other advantage of it is that when you have all the switches snapped into the key plate to begin with, you can press the whole thing down into the PCB, and you're much less likely to get bent pins on the switches.
Yeah, and that's what I found when I put together mine, was you could we had kind of a pre-assembled jig that allowed you to press the keycaps in without flexing the tray, and then you could just take that entire tray and just kind of align it, and just slowly just do kind of like an even press throughout it, and everything just went in perfectly, which is pretty awesome.
Yeah.
And these are people that are putting this together who may have never put together a part in their life. So you're having you're trying to simplify that experience for them.
Yeah, it's a big
We also
consideration with
did,
all this stuff. Yeah.
yeah. I think like last year we did a lot of poke yoke designs, right, where it could only be assembled one way, and this is kind of evolution from that as well. And actually on that, this was a graduate from last year. So once again, multi-jet fusion TPU materials were used because of their production viability and their ability to create complex durable rubber parts. So 3 components within this badge were 3D printed multi-jet fusion. You can kind of see a bunch of off-angle features, kind of a free-form geometry to this design. And I wanted to show folks what production additive manufacturing looks like. So this is a plastic powder bed fusion technology. And what you see on the right here is a nested build. So we 3-dimensionally nest builds to optimize how many parts we can build in one run. So this is a run where you're building hundreds of products at a time, which allows us to make thousands of products concurrently, as well as get you very quick lead times, even in a production scale with this particular technology, and technologies like selective laser sintering as well. And these were kind of the fun things. So we got to kind of show off some new technologies. LSPC was launched earlier this year at Xometry, and it is a DLP-ish style technology that grows parts out of a resin bath. And they have something called X-ceramic. X-ceramic is a ceramic-filled material, so it had a nice weightiness to it, as well as a good, kind of a good almost chalk-like touch. Like it's not like really, it's not going to come off on your finger or anything, but it had that surface finish to it, so it was great for the knob. And also, we were able to show off logos. So I think originally when we were scoping this design, we were talking about the keypad as 11 keys molded per unit. And they were like, well, what if we do a logo key, because we have PolyJet. So we were able to make these logo keys, which people were able to choose. One of those, some of us made some Xometry logo ones just in case they wanted those too. But these were the Autodesk Fusion and Xometry logo keys that we had at the show here. And what's nice about that is you tune those out to make sure that they had a good fit on the key tray, and then we're just able to press go. Control C, Control V on the digital scale, and just run a giant build of these parts, about 200 at a time. And this is the enclosure in the Autodesk kind of smoky gray, and that was made out of a Maclaron polycarbonate material, injection molded, and we'll jump into more details there. But again, that has those cosmetic requirements. It had that need to be translucent, need to be cosmetic and smooth, need to fit every time, and at the quantities needed, really made sense for molding. And similar with these keys, right? Very similar requirements. These are the cosmetic, the outer-facing components of this badge, and these are unique in the fact that it's not just one material molded. It is an overmold, so injection molding of a clear material and then a black material over top of that. So you could do things like what I show on the right here, where you can make one key but make it fully customizable through engraving. So if you engrave through that black outer coating, you're able to get whatever macro or command or number or whatever you want out of that. So on that, I really want to spend the remainder of this webinar taking a deep dive into the molding aspects of this. Scott, I'm going to pass the mic to you, and Jonathan, always feel free to have any colorful commentary along the way with experiences you had as well. But Scott, if you want to talk a little bit about our service and our comprehensive molding capabilities.
Yeah, absolutely. Of course, the perfect timing. My dogs start barking right as the mic is handed off, so hopefully they'll quiet down in a minute. Apologize for that. So yeah, molding at Xometry is exciting. We have a great network of suppliers that can provide parts of any size. Really, no part is too small, up to the statement that no part is too big for our network. We can really handle a wide range of tonnage from presses. We can do low volume, we can do high volume. We kind of pride ourselves on meeting you where you're at. So if you're in the need of a prototype tool, we offer those type of services for you. We also offer, as mentioned earlier, urethane casting, if it's even very, very low volume, as a viable option during your prototype stage. What people don't realize is that Xometry does also offer high volume production tooling, hardened steels, class 101 tooling. We can make those tools in different countries and have them shipped to U.S. stateside manufacturers, or we can do production really anywhere in the world at one of our partners. So it's pretty awesome. Our team is is a team of experts, many decades worth of experience on the team in different industries, anything from automotive to aerospace, medical, really any industry you could think of. We have team members that have been in that industry for years. Along with that comes custom manufacturing and custom materials. So we have the expertise to do highly engineered resins like your Ultims and your Peaks, all the way through your commodity resins of polypropylene and stuff. So we have a great offering from production tooling, any material that you'd like, and we also are handling the supply chain, handling our vendors through the quality inspections of the parts. We're kind of that turnkey production offering for you. You can also lean on us for if you're in the middle of a design or something and you need a little bit of design guidance and want to make sure that it's going to be moldable, we can support that as well. Along with that, we do secondary operations on parts. So post-mold machining, post-mold decorating, post-mold assembly. We really try to cater to your needs from a molding standpoint.
Yeah, this is really comes down to that theme of like celebrating the diversity of the manufacturers on our supplier network. Instead of being one big shop where all of a sudden we're constrained to only what we can do as a shop, we're connected to suppliers of all sizes, shapes, and forms. And that really allows us to align to their sweet spots. And as Scott was saying, if it's a production mold, if there's a pad printing afterwards, if there's a packaging requirement, that's stuff that we work with you on the considerations up front as we're building out our quote. And then we will help manage that process through the end. And what's nice is you are working with Xometry throughout. So we have the experts in-house and an incredible amount of experience, including Scott's experience, master mold maker here. And on that note, Scott, let's talk about the considerations for the two molded products of the enclosure keycaps. You want to run through some of those?
Yeah, so we knew that you had mentioned earlier, based on the size of the enclosure, that it was a little bit cost prohibitive from an additive standpoint. We were able to manufacture the tooling and the parts at a reasonable budget. The finishes you see there, the B2 for the cavity and C3 for the core, those are relatively common finishes for us. And then the smoky gray translucent polycarbonate is a pretty easy material to work with. So it led to a great decision to make that enclosure in molding. The keycaps based on volume and budget, right? So knowing that we needed 11 of these overmolded keys per device, we needed 600 of the 600 devices. We were able to utilize molding, and we'll get into more details about the way we were able to meet that budget in a minute. But yeah, we were able to do parts and the two tooling cavities for $10,000 or under $10,000. So
yeah. And that is, and like I said, I want to make sure that y'all know that's not just a tool; that's the inclusion of those parts. So that $10,000 is over 7,000 unique components overmolded, which is actually, if you think about that, that's 14,000 plus items because you had to do it twice, and as well as the tooling itself to produce that, which is not just one cavity; it's it's a second cavity being an overmold. So pretty amazing. And yeah, let's just talk about the strategy. This is, by the way, this is my favorite part of building this webinar, is me just kind of geeking out, and I was spinning the CAD and getting these images and really dissecting the tools. And I just, tooling is not just making the negative of the shape and somehow getting plastic inside. It is just, it's art. It really is art to this. So let's talk through, the steps with our customer. So Scott and Jonathan, as well as some of that tooling strategy.
Sorry, I've got a feedback here.
No worries.
Hope you can hear me now.
You sound great.
All right, sorry about that. All right, so yeah, so for the enclosure, the first thing we start off with is what's called a PEG, parting line ejection and gating scheme. The parting line is defined in the red lines that you see on the picture on the left. What you see, the little blue rectangles, we'll get to those on undercuts, but those are lifters. In the middle picture, you see some red rectangular shapes. Those are our ejection blocks. We're using the outside surface to eject the part with one little injection pin right kind of in the middle across that bridge. This part we decided to use a subgating subgate on. You can see that on the picture on the right. This was a cold sprue to a cold runner to a subgate into the inside walls of the part. That allowed us to keep the cosmetics of the majority of the part meeting the requirements of function. So.
Yeah, and gating, for those of you who may not be familiar, whenever we use gating, we're talking about the where the plastic is injected into the cavity to make that part there. So in this case, there's 2 locations where that injection occurred.
All of the topics that you see here are covered in our DFM up front. So when an order is placed, we go through our design for manufacturing event. Typically, this takes place within 48 hours of the order being processed. You get a DFM document that highlights all of this information. So next up is the undercuts that you see on the left picture. These are the clips where this enclosure clips into, I believe, the metal base. Those were our undercuts, so we have to release those from the tool using a lifter that allows us to give the part freedom to eject out of the mold without ripping that feature off. The picture on the right, the heat map that you see based on part thickness, shows a thin section of the part. This is due to a design constraint that Jonathan was facing with some components on the underside that need a little bit extra space. We did know that, highlighting this as an issue, Jonathan, I think you were mentioning yesterday that we made a great recommendation for adding a logo in that location to help with the unsightliness of the thickness analysis. So that worked out good for you, I believe.
Yeah, it looked great. It was a kind of a unique suggestion there. It wouldn't, not the kind of suggestion I'd expect from a manufacturer necessarily, but hey, you're going to need a logo somewhere, so this is probably a good place for it. It'll mitigate the whatever deformation you might have with that thin wall right there. It worked really well.
Perfect.
Yeah, it looked great. All right, and let's talk about the core and cavity. So, like I said, molds are not just simple. They're not just two pieces of metal. There's I think this one has 120, 130 unique components to it. So, yeah.
Yeah, the neat features of this, what you see here on the picture at the bottom left, you can see the locating ring. That's that green feature. That's where the machine, the mold gets aligned with the molding machine itself. The gray feature right behind that is where the nozzle will seat into the mold, where the plastic will be conveyed into the tool. You can see the mold plates, the ejector plates, and the springs on that design there. Moving up to the top pictures, the top left picture there where you have the green, you can kind of see these peripheral green lines impacting my cavity. Those are actually vents. So when you're filling a mold full of plastic, you have to have a way of getting the air out. So we utilize those vents to move the air out of the cavity so that the plastic can fill the part void. Other features that you can see there that are important are the cold runner and sprue. You can tell this is a full round cold runner with half of it in the A side and half of it in the B side. When I say A and B side, A is on the stationary platen, B is on the moving platen. As the mold functions, the machine has to move. You'll see a short video in a moment, and that's what those are relating to. The 4 little squares in the corners are a way for those blocks to align to each other. As the mold is opening and closing, you want to make sure that they go home into the right spot each time. That's how you can maintain a tight parting line with minimal flash or mismatch. The bottom left picture, you'll see these blue shapes reaching out of the part. Those are actually your lifters that are making those undercut features. those lifters are typically tied into the injection system. So as the ejector plate moves forward and ejects the part, those are moved at a 15-degree angle, allowing that undercut to be released. On the bottom right picture, you can actually see these are ejector pins, but what these are actually moving are ejector blocks. The ejector blocks aren't imaged here. You can see the pockets for them, but those are bolts that just screw into that block. So.
Yeah, and something that, as Scott was saying, we're talking about these undercuts, and it's a little bit difficult to see. I have the part in front of me, but these little tabs, they need to be formed, right? They're designed and they need to be formed. If it's external, we may have something like a side action that will go in and out to kind of plug that feature, and then you inject your plastic, and then you are able to move it out and release the object. Internally, we're using these lifters. If you imagine I have a little indentation on my finger, it's molded through, that indentation is making that feature, and then as the kind of like this tan object here is or sorry, this here is sliding back, you have it'll start to kind of move away. It moves just enough away that this part can move out. And it's this moves with it, and then you can move the part out with it. Sorry, it moves in after it moves out. It's easier to watch on the video, but I think it's just a really interesting, unique, because I remember like lifters were kind of a newer concept for me when I was learning more from you, Scott, about molding and how and when to use them. And this is just a really great example because we don't usually get to show people's like how things are made behind the scenes like this. So it's always fun to really disclose these unique aspects of mold design.
Yeah, so here you can see the video of the enclosure actually being manufactured. You can notice that this is a single operator job. The reason for that is we're having to manually push those lifters back. You'll see, we'll watch it one more time. If you watch closely, you can see the ejector blocks actually retract before the operator pushes the lifters back. And you can also notice that the runner is self-degating. That's one of the great aspects of the subgate, is it automatically degates out of the as the part is ejected.
So no die cutters there. And you can see, of course, this is the Xometry blue version being made. So again, we made a 50 sets with our blue wherever we could, and I actually did that. We did that last year with the factory experience as well. Why? Because we can. But it was always fun to show off.
Now for the keycaps. So we did the same process through DFM. You did the parting line ejection gating, and then you checked for uniform wall thickness, undercuts, and draft. Luckily, this part was designed very, very well. From a wall thickness and an undercut, there was no issues there, so that leaves us with an open close tool for both the substrate and the overmold. The substrate is the first shot, the overmold is the second shot. You can see here the first shots are in gray. You can see the ejector pins, the major parting lines. Take note of that green circle on the top picture. That was an insert that was placed due to some critical features we'll cover in a later slide. The bottom picture, you can see we're using a different type of gating scheme. This is what's called an edge gate. And then if you look on the right, you'll kind of see that we use two edge gates, and you may think, well, why would you gate from both sides? One is an actual gate where the material is being fed into the part. The other is what you call a bleeder gate, and that allows the material to flow through the part. It helps eliminate knit lines at the outgassing or the last place to fill on the part. Also helps us with filling this part because there were some thin walls across the top that we really wanted to make sure we could flow some material across and reduce the opportunity for defect.
Yeah, with this application, you needed only a thin layer of that opaque black PBT material because the goal was to have some sort of see-through when you're engraving in to get that LED light to shine through on the product.
Similarly, the cavity core set here, you can notice that insert is the black or grayish feature on the cavity that's closest to us. This is a family tool. We placed the cavity or the substrate and the overmold in one mold base in one tool that allowed us the ability to help hit the cost requirements. In the very center of that part, you will see what's called a runner shutoff. That allows us to make only one cavity at a time based on the location of where that gate is being fed from. Again, you can see the parting line vents and the bleeder gate on the coming off the side of the part, and of course the aligning features of those blocks in the four corners.
Yeah. And you know the vertical, so something to notice that compared to this one, right, this is going to be closing horizontally, and this is going to be moving up and down vertically. And you see that a lot with overmold or insert mold designs, where it allows you to have gravity work with you. So in this case, I'm putting that clear set in, molding the black over top of it, where if I try to do that kind of vertically, it could fall out, or I need some other way to hold it in place. And again, other common examples are insert molding. So say we have like 4 brass inserts on a project, using a vertical press will allow us to kind of pop them in place and mold through as well with gravity working for us. So yeah, we made our first sets, right? So the first sets that you deliver are for qualification before we produce, again, like 7,000 unique components, right? We call those the T1s. But in this case, there was something that came up. So Jonathan or Scott, if you want to talk about that.
Yeah, so got the shipment, everything looked great, and then tried them out with our switches, and they basically just fell off if you pushed on them and let go and let it spring back up. When it comes to this kind of stuff, when you're doing consumer product manufacturing and dealing with electronics, a lot of times you're kind of at the mercy of whatever store-bought component you're working with. In this case, it's Cherry MX switches. We're not going to make our own of those. It would be way too expensive. You're going to buy something off the shelf for that. And the tolerances that I was able to find for the product, which took a while, by the way, you can't always find that, were not exactly what were in the specifications. So they were a lot looser than what we'd hoped for. So I sort of panicked a little bit and called Greg on his cell phone and said, "Hey, this is too loose. Can we fix this in time?" And as you'll see here, it was no problem. So
we were able to make a steel safe correction to that pin relatively quickly. Within 24 hours, the tool was modified, and we were making plastic parts on day 2. So within about a 7-day swing, Jonathan had received his T1 parts, filed a need to change an engineering change to that size. It was completed, and additional parts were in hand. Those were approved. Of course, we lost a couple days with the production timing, and we were going to be in a tight spot for production. So what we were able to actually do is we left a single cavity on the substrate, but we duplicated the overmolding cavity, so we were able to do 2 at one time. You can see in the video here a single hand pulling the one component and a dual hand pulling 2 components. With this gating, with an edge gate, you do have to cut that edge gate. You could tear it off, but it may leave a rough surface. Using a die cutter or a side cutter to get that gate flush is a better option for us. You can also see for the overmold, you will have 2 of those, and they do come off attached to the part.
Yeah, this is kind of showing you, if you imagine actually kind of the middle of this bar, actually that's where the rudder shutoff is. So one side is doing one, and then you switch it around, and the other side is going to the overmold there. And so that allows you to consolidate tools and save some costs. And that's something really important to talk about, is this is the tool strategy for essentially what I would call a one-off run, where we wanted to reduce the pricing as much as possible to hit the scope of work and the lead time for this factory experience project. If this was 7,000 a week, we'd have a very different strategy, right? Multi-cavity molding, possibly 2-shot automated molding, and different alloys for tooling, and the whole kit and caboodle. But again, we listen to what your needs are, and we work a strategy out with you that fits your scope. And so this is a great chance. We're going to talk a little bit about some resources where you can find more information in a moment here. But please, I see some questions coming in. Thank you all so much. And please continue to ask. Like I said, you could over ask questions because we're going to answer as much as we can now, and then we'll also follow up with you afterwards. So please get your questions ready. And I want to just talk a little bit about how this experience starts. Like I always, I had the chance to, I don't know, do like 200 pitches at the factory experience when we talked about this. And, I always just started by holding this object up and said, this started with a Xometry quote. This is what a Xometry quote looks like. And this is true. Like it started with the upload of the 3D CAD files, configuring the materials, putting in your quantities, and then pressing buy. In the case of injection molding, you request the quote, it goes to our team, our estimation team, and we had that conversation to make sure that we're getting all the details together and build that strategy together. But this is the power of the instant quoting engine, 24/7 access through other apps as well. And you're able to go with over 20 different manufacturing technologies. And so this is something that's accessible for you. It's free. It's not a downloadable software somewhere. It's just go to Xometry.com and you can upload your files and give it a try right now. We do read prints. We do hit specifications. We are ISO 9001. We're AS 9100. We have parts in the air, parts in space. We're 13485. We create medical devices and components. And we also work with Department of Defense and other entities that may require export restrictions and controls. So we really are able to aggregate a lot of demand and from a very, very wide customer base with the power of our digital marketplace.
If I could just jump in there real quick, Greg.
Yeah.
Something you don't see so much when you get a pitch like this is, you see the cool website and all the options for manufacturing and how the quote engine works, and that stuff's all great. But when I send a part to Xometry, we get there's a full design review and all that stuff. Design for manufacturing comes back, but the recommendations you've given us every time we've done this project have been stellar, and just ways to save a lot of money and get a better quality product and all that. The expertise your team has, especially working with Scott on this last project, it makes a huge difference when you're going into production for something. So a big part you don't see from the pitch, but remember that.
And I'll also give a shout out to Kyle, who was also your day-to-day point of contact on the molding side. And I know Scott and Kyle were pulling miracles left and right, and I think that was it's just really something that our miracles become our norm. Like it becomes and I think one of the neat things about us is we are exposed to so many unique use cases and manufacturing cases that the weird is still normal for us. The exceptions are our rules. So it's, sometimes, it's, a quick mold, but sometimes it's not. And we have the right team involved with that as well. I did want to, again, highlight the app for Fusion 360. You can find this. So if you go to the Fusion 360 App Store, it's a free app to use. And it'll give you access to essentially it creates a little 360 frame. You can select the bodies that you want to quote, add that this is quote, select material, process and material, get some preliminary pricing, and you can also jump immediately to Xometry site where if you want to go dive deep in the details, add inserts, surface finishes, tolerance, inspection requirements, you name it there. But that allows you to very quickly get feedback while you're still in the driver's seat of the design. And for those of you who may not be using Fusion, we do have an app ecosystem. So a similar app is for Inventor, right? Autodesk Inventor, as well as SolidWorks and Onshape. So those tools are available, and it is really nice to meet our customers a little bit upstream, especially with some of that DFM feedback that we have. For those of you that are learning, I actually saw some questions about where can I get some great resources. A lot of my job is building good resources, or hopefully good resources for you to learn and discover all these different manufacturing technologies. Xometry.com is a great place to start. If you click under our solutions, we have capabilities pages for every technology we offer. Think about each capability page as also almost like a metro hub, where also take you to other useful resources around that technology stack. We have design guides available, ebooks, and a really great blog where you could go and learn more case studies, as well as find these fun on-demand webinars, including this one. This is where the recording will be held. And on that note, let's do some Q&A, And also just want to support you all, like with, if you have a project coming up, take a look at the code here on the screen here. This will give you $25 off your next Xometry order. And we also have a promotion for a free trial on Autodesk Fusion 360. So if you want to give that a shot yourself, we also have a code here with this QR code. And when we do an outside email, I'll send you the direct link for that as well. So again, thank you so much. And let me just jump into some of that Q&A that we have going on here. So actually, one of the first things I saw was, how can I have a conversation like we're having today on the webinar? Like, where do these conversations start? And I will say, like, some of the best ways to find us, you can contact us through support@xometry.com. We have live chat on our website. And also just generating that quote is one of the best ways to get involved with our applications engineering and our technical team. Before you have that, like a design to review, we're kind of talking speculative, right? Can you or should you or do this? But once we have the design, it speaks to us. We're really able. Yeah, go ahead, Jonathan.
I can attest to that, because even though Greg and I talk all the time, we have each other's cell phone numbers. Even for this project, I was like, hey, we're going to do this keypad thing. What do you think? And he was like, just put stuff on the site. Like, what are you doing? Upload your stuff. And it's like, cool. It's the way we start conversations too. Yeah.
Yeah, no, absolutely. And again, it's just because that way it gets our mind thinking, even stuff like, hey, what else can we do some really neat things? Like what technologies would fit here? It really starts getting the gears turning, and we're always happy to kind of give some insight and also recommend processes, again, based on time, scope, and cost. So for design for molding resources, so Brian asked that. I think that's a Brian I know. So hello, Brian. We do have a design guide. So if you go to our capabilities page under our solutions, injection molding, you should be able to find a link to our injection molding design guide, as well as they have some design ebooks there. Ultimately, though, everything has its own unique components to it. So also understand that sometimes get that CAD up, even if you're in the 3D printing stage, please tell us that you're looking to mold it. Because if you're 3D printing and eventually it's going to move to mold, we could help get you that DFM feedback in parallel while you're doing your iterations, and it will save you so many headaches when you move to different manufacturing technologies, because 3D printing loves design for molding, but molding doesn't always love design for 3D printing. So try to get your technology in the right path, and because we do both these technologies together, we're very happy to help work with you and make sure that that you're on the right track. Scott, I got a question for you. Does the customer own the mold?
Yes, the customer does own the mold. It is
in my case, the customer also has the mold.
Yeah.
We brought it to the show with us.
that comes with a disclaimer, right? So if you have intentions of moving the tool at a later date, we need to know that up front. A lot of times, if you're seeing a cost-effective molding option, from a tooling standpoint, you are not purchasing an entire mold. You are purchasing a cavity core set with what's called a shared mold base. That shared mold base is retained at the mold or at the mold facility. In this instance, we were able to actually send the cavity core blocks of the enclosure to Jonathan to have on site for this. So these blocks were actually shipped. But you need to be careful if you're buying an economic mold, that you may not be able to transfer that and immediately start making parts.
Yeah, and just kind of showing you what Scott means here. So this would be like a modular frame, if you will. And if I hide these features here, oops, well, if I do this correctly for you all. You'll see that this is that core and cavity. So this is where the magic happens on that mold. And so that this stuff is kind of unique to that tooling, but just kind of showing you there's the base, and then there's also the cavity core, those inserts. And as Scott says, this is where our conversation starts. So depending on what your intentions are, please over communicate to us with your goals, because we get it and we want to make sure we're making it right for you.
And if you have intentions of moving moving a tool, just understand that different mold shops have different press requirements. They have different standards within the company. So you may have different electrical connections. You may have different water connections. The interface between the tool and the machine may need to be modified as well.
Yeah, absolutely. Now, Jonathan, someone's asking where can I get one of those sweet macro keypads? So I may get you guys connected after the show here. Now we did make, full disclosure, like we did make a set for the Fusion, for the factory experience. So we made 600 sets, give or take, and so a lot of them were consumed. So I'll let Jonathan's discretion there.
Yeah, we've got some leftovers. Your best bet is to go to AU next year, because I'm fairly certain at this point that we'll do another version of this product using the same PCB and a new enclosure. I think I want to do bosses this time, and Greg had some ideas about like multi-shot injection molding with like maybe a TPU or TPE, something flexible along with the polycarbonate. There's some cool stuff we could do there. So that's your best bet.
Yeah, I'm actually pretty excited to show off overmolding more. Like the keycaps, you don't always see, like, this is actually complex overmold, especially when I don't have light shining through it right now. But being able to show like a soft touch integrated component could be something really, really cool. And yeah, we're idea generating right now. So there's a question like, hey, jumping straight to mold is not really where I am right now in my project. What are some good alternatives to prototype your molded aspects? And this is where I'll highlight we have 9 different additive manufacturing technologies available. I can tell you that 85 to 90% of the time as you're prototyping, you're going to be choosing multi-jet fusion or SLS, particularly the nylon 12 variants, because it's just so dang useful. Like, it's design forgiving, it's durable, and it can really hit some really good, decent tolerances on it. But ultimately, you may be changing your technologies depending on your production needs. Like, is this going to be viable, but I'm going to be bridging it, and it's a rubber component. Maybe we look at something like carbon DLS or Nexa LSPC. Like I mentioned earlier, I think stereolithography is a great insurance policy. So even when Jonathan's like, I am, the revision's locked in place, we're definitely ready to go, I would still recommend SLA printing a part and assembling it. Because if you find an issue there, that issue will be repeated 600 plus times, in the molded out project. So it's easy, like it's easier to spend, $100 on a enclosure SLA prototype and catch that early than do like, full tool grooming there. But we're always happy to give suggestions.
Yeah, I mean, in our case, it was the polycarbonate was the enclosure, the main enclosure. Mm-hmm. And then the samples we got, the 3D printed samples to check it out, were SLA, and dimensional accuracy is about as close as you can get. But the SLA is less durable, so clips tend to break off and stuff like that. Just one thing to keep in mind, that with the injection molded parts, you're not really going to get an additive, product that, you probably got some of the clips are probably broken off that one, right?
PolyJet does the same thing. Yeah.
Yep.
I think it had 0 actually survive all my handling and transport between the show and now. It's good. Like some technologies are great for concept demonstrations, but don't give it to your customer. Like they will break it, and I will break it. I've handled a lot of 3D prints in my life, so it's saying something. So I have Scott. I'm going to give a couple more questions because we're a little bit over here, but it's just a question about silicone molding, Scott. And I'm not sure if you want to give a quick pitch on what we do there with silicone products.
We do it. We have suppliers dedicated for LSR molding. It's a little bit different than injection molding. You're heating the tool to set the material, so it's different than just a traditional injection molding, but we offer it. Similar processes, of course. Depending on the material and the geometries, we'll communicate the best techniques for you.
Yeah, and that's something to also mention is there's more than one way to make silicone products, and something we also will take a look at that design and consider, depending on what the features are, would be something like compression molding, which can make actually I got a toddler 2 toy This is an example of compression molding where you wouldn't mold a design with this type of thick, thin geometry, but it's a good example of using compression molding to create a project there. So I'm going to take the last question is also around molding here, and it's just about our international versus domestic supply. So in this case, we used international supply to hit budgets and lead times and scope, but we also do have a domestic supply chain. Scott, if you just want to talk a little bit about what our domestic supply chain is and some of our capabilities there, and we can finish that out.
Sure. Yeah. So we have many U.S. Mold makers within our network, as well as plastic part producers, and some of them work together. Some of them are the same company. Same thing with our China network and our global network, I should say. Mold builders all around the world. One of the biggest things we run into currently are the large tariffs and shipping costs of getting materials imported into the United States. Oftentimes, we see that at the end of the day, at the very end of the project, and you've moved tools and moved parts, initially it's about 3x to stay in the U.S. But after you add in all of the extra fees and tariffs and shipping, it's really not that much of a difference depending on the product and the codes that are associated with it. So, each project's different, each geometry is different. There's pros and cons to both, and we're here to support you navigating those decisions and navigating those suppliers. That's where our expertise really comes in.
Yeah, and that includes things like export restrictions, like ITAR mold shops we could do domestically, and even shop level certifications, like ISO 13485 for medical device manufacturing, clean room manufacturing. Again, talk to us. I think that's the most important thing, is let us know your requirements, where you are in the project, and we can really help devise that strategy. With that, thanks so much for hanging a little bit, a few minutes over here. But Jonathan, Scott, thank you so much for being our guest. And Jonathan, what an awesome project.
Yeah, can't wait for the next one. I love working with you guys.
Neither can wait. Look forward to it.
All right.
Thanks, Greg.
Awesome.
Cheers,
Thanks, everybody.
Have a great day.